this lesson, we'll be identifying relations. By the end of the lesson, you should be able to represent relations as a set of ordered pairs, tables, mappings, and graphs. So a relation means that there's a set of input and output values, and two different variables have a relationship. It can be represented as ordered pairs, as a table, x values and y values, as a graph, as an equation, as mapping, and verbal. So the mapping, remember we list them, x and y, all of the x's, all of the y's, in order, least to greatest, and only one time. Independent and dependent variables. Independent variables are the domain, which is the x-axis. If the variables are different, like they use m and n, then m is the first one, domain, and n is the second one, which is the range. The dependent variable is your range or your y-axis, or if it's other letters, the second one. So some examples. So say you have this pattern of these figures, and we're going to make a table with this information. So the table would look something like this. The number of squares, 1 square, the perimeter is 20, 2 squares, the perimeter is 30, 3 squares, the perimeter is 40, and so on. If we wrote that same relationship as ordered pairs, the ordered pairs would be 1 and 20, 2 and 30, 3 and 40, 4 and 40, 4 and 50, and 5 and 60. If we wanted to show that relationship as a graph, it would look something like that. If we show the relationship as a mapping, we put the x values in numerical order, 1, 2, 3, 4, 5, and the y values in numerical order, and then we connect the x with the y. To represent this in words, we would say the pattern shows that the perimeter is the number of squares times 10 plus another 10. So that means the equation would be 10x plus 10. The variables, the perimeter depends on the number of squares. So the independent variable is squares and the dependent is perimeter. So we'd like to sketch a graph to represent the situation and label each axis. So during a trip, your speed increases during the first hour and decreases over the next 2 hours. So your graph might look something like that. In the next example, the average temperature steadily decreases over the course of the football season. So your graph might look something like that. Temperature is going down over time. And the third one, the average test score of the class increased throughout the semester until it slightly decreased on the last test. So we have something like that where our test score is increasing and then sloping down at the end. Describe the graph and identify the independent and dependent variables. Well, here on this first one, we've got your major and your GPA. So it looks like the art major is high, and then English is a little bit lower, and then history is the lowest, and then math goes up. So your dependent is your mean GPA, and your independent is the major. Here we have a hot air balloon that's going up. It kind of levels off and then comes down. Our dependent is the height, and our independent is the time. Here we have a taxi driver that goes fast, speeds up, keeps a steady pace, slows down, actually stops, goes up, steady pace, down, goes up, steady pace, down. So our dependent variable is the speed, and our independent variable is the time. So we're going to match an independent with variable, independent with a dependent. So your cell phone bill depends on how many units you use. The cost of your speeding ticket depends on the speed which you're driving. How far you can drive depends on how much gas is in your tank. How much money you earn depends on how many lawns you mow. How tall the grass grows depends on how much rain there is. So which axis is the independent variable? The x-axis. And which one is the dependent variable? The y-axis.